Lesson 7, Reading 1, is burning a chemical reaction. Getting ready. Chemical reactions occur all around you. They do not happen just in the laboratory or in science class. For example, when you light a sparkler, you observe a chemical reaction. Embedded text-dependent question. What do you think the old stuff and the new stuff are in the chemical reaction that makes a sparkler light up? Now read about sparklers and the chemical reaction that makes them light up. Why do sparklers light up? When your teacher burned magnesium in class, were you surprised by what happened? Burning is always a chemical reaction, even though it does not always make such a bright light. The reaction you saw in class was similar to the reaction that occurs when you burn a sparkler. Sparklers can be made of different metals, but all sparklers work in a similar way. As a sparkler burns, the metal of the sparkler and oxygen from the air interact and form a new substance. The reaction would take a very long time if you just wait for it to happen. A flame gets a reaction started quickly. Often something needs to happen to get a chemical reaction started. Substances may need to be mixed or heated first. Even if you mix all the right ingredients in the kitchen, they do not become a cake as they sit on the table. The ingredients need to be mixed and cooked. Then they interact to become something new, a cake. In class, your teacher lit a magnesium strip with a flame. When the oxygen and magnesium interacted to create magnesium oxide was a new substance. As you saw in class, a reaction also produces bright light. The reaction is similar to the reaction that happens when you light a sparkler. Fireworks are another similar reaction. Once a flame lights the fuse, a chemical reaction happens to cause fireworks. Fireworks can be many colors. You have probably seen green, red, and many other colors in the sky. Think about what you have learned about chemical reactions so far. Embedded text-dependent question. What do you think makes fireworks different colors? What is a chemical reaction that makes fireworks work? Think about what you see and hear when you see fireworks. First, you hear a loud noise. Second, you see something shoot up into the sky. Third, you see a burst of color in the air. What chemical reactions make this happen? When a flame lights the fuel in a firework rocket, a chemical reaction occurs between the fuel and the oxygen. This reaction produces a gas. The gas escapes out of one end of the rocket, causing it to shoot into the sky. Once the rocket is in the sky, other substances inside the rocket are lit. These substances react with the oxygen in the air. This reaction creates the burst of bright colors that you see in the sky. When you see many colors, it is because many chemical reactions are occurring. Each color and each sound is created by a different substance involved in different chemical reactions. Reactants and products in chemical reactions. In a chemical reaction, the old substances that interact with each other to form new substances are called reactants. The reactants are the starting substances in a chemical reaction. It may help you to think about the reactants as the substances that act together. In the sandwich bag experiment, the substances you started with in the bag were the reactants. The products are the substances you ended up with after you tipped over the test tube. The products of a chemical reaction are the substances you end up with. They are new substances. Scientists represent chemical reactions in a variety of ways. In the representations that precede and follow, you see an arrow. The arrow is an important symbol scientists use when they write chemical equations. The arrow means goes to form. You could think of it as changes to. The paragraph about sparklers tells you some of the reactants and products when your teacher burned magnesium in class. Embedded text-dependent question. Look back at that paragraph and find the reactants and products. In the following space, write a chemical equation that shows what the reactants and products were in that chemical reaction. When you write about a reaction, you are writing a chemical equation. A chemical equation is a way to represent chemical reactions. The equations include plus signs and an arrow. Notice that the reactants side of this chemical reaction has a plus sign. Usually in math, a plus sign means adding or combining. In a chemical equation, the plus sign means that the reactants are interacting. In some chemical reactions, the old substances interact by combining and forming one new substance. In other reactions, the old substances interact and form two or more new substances. What other ways can I represent a chemical reaction? Previously, you represented the magnesium reaction with a chemical equation. It included the substance's name and the plus and arrow symbols. In class, you represented the substances in other ways. For example, you used molecular formulas, numbers, and letter symbols of atoms to represent substances. You also used marshmallows to model how magnesium, metal, and oxygen gas changed and a new substance formed. What follows is the magnesium reaction in a chemical equation, this time using a molecular formula. This chemical equation tells more about the atoms and molecules of each substance. You can see the number of atoms and the types of atoms. You can see the number of molecules and the types of molecules. You can see which atoms and molecules react and what they form. A chemical equation can help you understand what is happening to the old substances and the new substances in a chemical reaction. Look at the symbols for magnesium, oxygen, and magnesium oxide shown previously, using the following space to draw a model of what happened in this chemical reaction. You may choose to draw atoms as marshmallows if thinking about what you did in class is helpful to you.